Okay, so this is the MicroJIT community meeting for the 22nd of October. So as has become our tradition, I'll turn the floor over to Scott from the University of New Brunswick to give us an update on how things are going.
Perfect. Thank you very much, Andrew. There's been a new push to the pull request. We have a working implementation of the switch to GCR, so there is no more extra 2 field. And this has been tested, and we've shown that it gets the recompiles working, but we made some modifications from the original idea, and specifically, we are currently testing it and working with it without guarding. So even when the machine is first starting up, we are counting things for recompilation with MicroJIT specifically. Now, the reason we decided to do that was kind of multifaceted. One was because we were getting a weird case in our kind of small bespoke benchmarks that we were using with these limit files to limit compilation to specific methods for testing, where it wasn't changing the state of the VM unless we were debugging things with GDB, which made it very hard to then determine whether things were working correctly or not. And because of that, we decided that the best thing to do would be turn off the guarding inside of the code that's generated by MicroJIT. But the more I thought about that, the more that sounded like the right thing to do anyway, because MicroJIT is going to compile things incredibly early, and the recompile that's triggered by MicroJIT is going to be the first compile TR otherwise would have done, which makes sense to want to do when we're starting the VM up anyway, because we would want to compile those things with TR if MicroJIT wasn't there. So I'm thinking the more I've thought about it, the more I feel like that might be a thing we just leave as is long term. Now, there was a caveat, which was when I was implementing GCR, I wanted the counting to be the counting, or to be the count that is set for a method for TR to use when TR goes to compile it. And the downside there is that the function that does that is inside of the bytecode interpreter, and it also checks a number of other things about the method and the state of the VM when trying to figure out whether it should or shouldn't compile things. And I didn't want to try and hook into that or call that in the middle of generating code and compiling in MicroJIT, especially since it had other side effects and was setting other things. And I also didn't want to go in depth into trying to rewrite it so that it didn't change state and would recalculate the thing when I needed it to. That seemed like it was going to be fairly extensive. So what I instead did was I added, or rather replaced the extra 2 field with a smaller field that's only 4 bytes for holding TR's count. I'm thinking that it's probable that we could maybe reduce that to 2 bytes. But at the same time, I'm thinking that if the counts are low enough for TR's count and the count we expect to be provided for TR is low enough, we should be able to also use some bits in that field for various flags that'll allow us to easily check things like if we fail a compilation with MicroJIT. Right now, if that fails, then the next time it goes to compile, it's going to try to compile it with MicroJIT. So it would be convenient to use some of those extra bits in there for saying things like this was attempted with MicroJIT already and there was an unsupported bytecode, something like that, or MicroJIT failed to compile, and should not reattempt with MicroJIT. And that way, when that method later on gets compiled again, because we can just set the count then to be the TR count that was in that field already in the extra field. Then when we look at that TR count field, we'll be able to check the same way we check to see if we shouldn't attempt to compile things using the extra field. We'll just check a bit and see, should we compile with TR or MicroJIT? So that's kind of like what I'm looking at as possible changes to this, or future features. But right now we have a working version of the GCR with those caveats, the TR count field on the J9 methods, and the fact that it's not guarding the counting operation inside of JITted code.
Marius, do you have any comments on that for this version of the pull request? Is there anything else we need on that particular aspect from a control perspective?
So I'm okay with not the count being not guarded because I thought the initial goal here was to replace the extra two field, which was counting always. So this implementation achieves just that. It's going to count always until this so-called GCR count, it's not guarded, but it's just a new count, is reaching zero. When that happens, we are going to trigger a normal JIT compilation. You have more flexibility if you have it guarded, but then we have to decide when we want counting and when not. So I think this should be addressed later on when we are going to start to play with heuristics.
Okay, I think that sounds okay. I think there had been a concern about the growth and the size of the J9 method because of adding the extra field. So we still need a field there for this other counting, or this other count, right?
Okay, so I didn't understand why that field stays in the J9 method. Why? Yeah, because there is no other place. How do we do this in?
So what is that extra field
So
being
yeah,
added?
we should have a persistent JIT body info, and the count can reside in there, can't it?
Yeah, the problem is that the count is set in the bytecode interpreter before a JIT compilation. So essentially what's happening is there's this big method when it's loading this up that sets the count for the extra field in the J9 method structure.
Right.
And TR has a number of things that it's checking when it sets that count. And if the MicroJIT count is going to exist in the extra field and be used as the initial trigger for counting, then we still need to have that TR count stored somewhere because we need to know what it is when we go to patch the GCR code with the initial count value so that we know how many times we should count the method in when executing it after MicroJIT compiles.
So,
sorry, go ahead, Marius.
So that count that we set is also based on heuristics. And now the heuristics about the count that should be placed when moving from a MicroJIT to JIT should be different. So I wouldn't necessarily take that count as it is and use it for the transition from MicroJIT to JIT. It should be a different count based on a new set of heuristics.
Okay, so would you say then that what we could do is remove that field from J9 method entirely and then just grab whatever count, like have a default or reference the same default?
Yes.
That, all right. Because I noticed that there was something that was multiplying the TR count by like a value if it was early enough in the system state.
Yeah, that was about the S count methods that are AOT. So I don't think these things apply to you. We just have to come up with a new set of heuristics that decide when we want transition from MicroJIT to the JIT.
All right, that's not a hard change. We can just remove the field, go back to essentially checking to see if we're using MicroJIT, and then and if that method has already been set with MicroJIT, and if it has, because MicroJIT's count gets set before TR's. And so if MicroJIT has already set the extra field, then we just exit early from TR setting account, and then we use the options, the value from the JIT, or we can use the option from the JIT options, the value from the JIT options for setting the count field inside of generated code.
Yeah, I think that if it's probably going to lower the concern from the VM side as well, because they're always concerned about the growth of those data structures just because there's so many of them allocated. So I think that's probably a reasonable approach for this part of the PR. It'll minimize the impact on the rest of the system when this lands. So, all right, great. That sounds like great progress. It's great that the counting is in the templated code and doing the right thing. That's really good.
So how many bits are available in the extra field?
Probably not many.
Probably none.
Yeah, well, I was approximating none as not many, but yeah.
Yeah.
Most just about anything in the method or the class that has flags, most of the flags are used.
Yeah, I wanted to get an extra bit in there. No, it's not going to happen.
Yeah. All right, fair enough. I was really hoping that the extra field, because like I know it's shifted by 1, and so the very last bit is used for some stuff with counting when you haven't compiled a method yet. I was hoping there'd be an extra few bits there because it's a pointer. It's 64 bits. I figured there might be some extra space there, but I guess not.
No, so I had a proposal long time ago, but it didn't get implemented, where this 64-bit entity could be used 32-bit as a counter, counting, and 32-bit for something else, basically flags. But that never got implemented.
Okay.
Yeah, I mean, if there's a need for flags, then it's probably good to try and outline like what it is the flag is for and where it would be used, and then have a discussion with, because those design choices require sort of agreement between the interpreter people who are the gatekeepers of those data structures and the JIT folks. So those tend to be slightly more involved discussions because those data structures are sort of size critical because of the number, and they're also performance critical. So getting space in them tends to require one to have put together a very good case and convinced most people that there's no other alternative.
Fair. All right. So when I'll see if I can find any alternative way of signaling to TR that something has been compiled or MicroJIT attempted to compile it and failed. And I can probably use the persistent in the same place I'm storing that we compiled something with MicroJIT or not. I believe it's persistent.
You're fading out a little bit there, Scott.
So there's a pointer that's saved inside the code to a persistent structure.
Yep, the persistent
that,
or whatever.
Yeah, inside that persistent structure, I added a field to say that the thing had been compiled with MicroJIT. That way, if we were recompiling something, I could check to see if the thing was compiled with MicroJIT, or had already been compiled with MicroJIT. And then if it had been, I could compile with TR, right? And since TR is never going to set that flag to 0, any recompilation attempts will similarly go to TR and never hit MicroJIT. So I can probably just set that same flag or turn that flag into a bit vector and add another flag to it. And then use that to signal that we attempted to compile with MicroJIT and failed. Because that data structure is allocated before we compile things anyway.
Seems reasonable to me. Any concern, Marius? You're on mute, so I would guess no concern.
Okay, no. I wanted to say something. If you are talking about the JIT body info, so that data structure indeed is allocated before we start the compilation. However, if the compilation fails, we deleted it. So don't count on it being available when the compilation failed.
All right, that's significantly more worrying then.
But
Well,
I think
we already signal failed compiles, though, right, Marius? We know not to recompile something, for example, if it's failed too many times, right?
so if there is if you're talking about a recompilation, yes, we have the JIT body info and for the previous compilation and whatnot. If you have just a first-time compilation, then we set some flag, I believe, in the extra field. Is that true? I think we definitely can use the extra field to say never try to compile this again.
Yes, I'm familiar with that. I've
so
seen that
there are
all.
the counts that are negative numbers have a special meaning. So one of them, or I think -3, means don't try to compile this ever again. -5, it's cute for compilation, and there might be others.
Okay, because essentially the problem I have here is that if I'm looking at an extra field, or even just looking at a J9 method, and I want to say, should I compile this thing with MicroJIT or should I compile it with TR? What I try to do is essentially identify, should I compile it with MicroJIT? And the way I'm currently identifying that is if the thing that I'm going to compile is essentially queued for or has been set to be compiled, but isn't being set to be recompiled and hasn't been compiled with MicroJIT before, and we have turned MicroJIT on as an option at the options level when starting the Java virtual machine.
Though I don't fully understand your problem, because if the intent is to not let the method run interpreted, so let's say you try to compile MicroJIT and you fail, but the intention is not to continue interpreted and try the JIT compilation, TR compilation. You can do it right away because you know that you failed. You don't have to set any bit anywhere. Just start a brand new compilation using the TR compiler. And if you don't want, if you don't want and you don't want that to be compiled, you just set the extra to be the negative number -3, never compile again, and you're done.
Okay, so here's the problem. The problem is that I don't want to immediately compile something with TR if it fails with MicroJIT, because MicroJIT counts from Federico's paper. It looked like he had a count and a B count option set up, and when the B count was set to his heat map that he had for count versus B count settings showed that there was almost no sensitivity to count, and it was only sensitive to B count. So we're just going to treat everything as one kind of method, whether it has for loops or not. And then his value that he had found that there was a sweet spot across all the benchmarks he ran around 20. So we initially were looking at starting with like a default of 20 and the ability for people to set an option. We definitely don't want to compile any method with TR with a default count of 20, because I think even Quick Start only uses like 500 or 1,000, something like that. And so
right. So wouldn't it make sense then, Marius, to have something like the failed MicroJIT queue of TR compiles, and you could pick up when to process them from the control logic?
Yes, we can definitely have a queue in there, and but so if there is nothing counting, how are you going to pick something from that queue? Or we can devise a logic, but I'm not sure who's going to do the counting. So is the interpreter going to do the counting?
So the way that
instead of a queue, you can actually have a whatever data structure that you want to keep around for every method. You have an entry, and if when the compilation counter reaches 0, if you have an entry there, it means that you've already tried with MicroJIT and you failed, and therefore you do a full JIT compilation rather than MicroJIT. So you can definitely have data structures around. I was trying to find you an available bit starting from the J9 method. I believe there is a relatively convoluted way to get you to a field where you have bits available. So it's not going to be as fast as checking the extra, but I don't think you care at that point.
No.
Yeah, so I'll try to find you those extra flags in the J9 method. I think there is a way.
Okay, so if there's an extra flag of some kind in J9 method I can use, that's sufficient for me, because all I want is to essentially, when MicroJIT fails compilation, set the count in the extra field to TR's count minus whatever MicroJIT count was. Then we get an easy, like we can just use the regular path that the interpreter uses before when MicroJIT wasn't there, right? Then when TR comes, then when it goes to be compiled again, I just need something where I can look at the method and then say, did MicroJIT try to compile that? And if it did and it couldn't, then we want to compile with TR.
Can we use the persistent method info? Is that created before we compile? Because there's only one of those per method, right?
But
And the problem is that it gets deleted if we fail that first compilation.
yeah, we made
the persistent JIT info, but the persistent method info, there's one per method.
Oh, okay, I see what
Okay, yeah, that may work if we don't delete it. I'm not sure if we do.
Yeah, the persistent method info, I don't know the first. I can't imagine why we delete it unless we never compile, because we might never need it. But
yeah, that could work.
also, I had a question before my audio wasn't working. When you do a MicroJIT compile, how do we trigger and it passes? How do we trigger a regular TR compile afterwards? Is it just the other mechanism we use, like the sampling mechanism?
It's so essentially the code that's generated by MicroJIT. Every MicroJIT method generates a guarded counting block at the start, except it's not really a guarded counting block because there's no guard. And then it operates the same way GCR would. So it even uses all the same paths that GCR does. So when we'll put this in the queue to compile, and it goes through the same, or queue for recompile as if it was GCR. And then the method, when it or rather when we put it in that queue and we call that helper function, it looks at it and treats it just like any other TR method that called that. And it goes in and overrides the section of the prologue and calls the appropriate function to queue the method for recompilation and set it all up.
Okay, I see. All right, that makes sense.
Yeah, and then in the persistent JITted body info, we added a field to basically say we compiled this with MicroJIT. And at the very end of compilation, or rather during compilation, we set that field to a value of 1. And then it's initially, when you create the persistent JITted body info, it's set to 0. And so if we compile something with MicroJIT, this gets set to 1. So then when the recompile happens, we just check that field, and if that field exists in the persistent JITted body info, then we shouldn't compile with MicroJIT.
All right, makes sense. Yeah, so there might just have to be some sort of. You may have to. I mean, it's unfortunate that you have to split some of this data into the persistent method info and the JITted info, or the body info. But maybe there's a way you only have to use one. I don't know.
Yeah, I found that other flags. So there is a method called fetch method extended flags pointer. And it will give you a pointer to some extended flags. And it's more complicated to get to them, but I don't think you care, so you can use this. I'll paste it during the private chat Slack channel.
Awesome. If there's something quick that I can do to take that concern away and bring it down or bring the J9 method down to the same size it was before, then that's great.
Unfortunately, I have to leave. I have another meeting.
All right, no worries.
Yeah, okay, thanks, Marius. I think we got through a lot of the control stuff anyway there, so.
Okay, thank you. Bye.
Bye. All right, so that's mostly it for me. I'm planning on, now that, like, once I get these changes in for GCR, to move on to the J profiling work. I still have all those links, and I may rewatch those videos you sent me before, Andrew, just to get kind of refreshed on it. But essentially, I'm planning to, as a first pass, just grab whatever data we have from the interpreter profiler, however it's done, and I may need some pointers into files or methods inside of the JIT, where it gets that info from the interpreter to build up the JITted profiling call graph, or however it is that it creates this graph of nodes and edges. And once I have that, I'll basically try to mimic the same thing from a non-intermediate language perspective for MicroJIT. And then I'm going to try to figure out if those two things will be compatible with each other, which, if I remember correctly from last discussion, we said should just work because we're going to pass a CFG, and the CFG is based off of the byte codes, or rather it's based off the IL, and it's not going to change, or we should get the same CFG even if we start from byte codes.
Yeah, so CFG you should be able to build the same kind of CFG. We can probably try to recycle some of the basic data structures there to do it, and then hopefully you might be able to pull out the algorithm itself so you don't have to do the whole thing yourself. It's probably the most sensible thing to be able to add the instrumentation to your method. Yeah.
All right. So Harpreet is on the call, and she has recently finished up the work she was doing on the most recent bytecode template she was working on. So I think now she's just starting to get into and look at the properties and linkage refactor. So I'll transfer this over to Harpreet and let her ask any questions that she has and update you on that.
Okay, thank you, Scott. So Scott already updated that I finished with the implementation of get field and put field, and now I have started working on the linkages. So I'm just doing it. So just a very quick question for this time, that so basically in the linkage refactoring, we are supposed to separate the properties from the linkages. So I came to know that there is an OMR test suite that we can use to test when we are done with our linkages. So is that the same as the FV test component of our Eclipse OMR project, or is it something else? Like which test suite we can use to test the linkages?
So you're going to need to use two different sets of tests, right? Because OMR has its linkage implementation, and OpenJ9 extends those linkage implementations and adds some of its own. So you can't just test OMR and you can't just test OpenJ9 when you go to change the linkage operation. You're going to have to check both. So there's the FV test stuff in OpenJ9, and in OMR, there's, if you go and look, there's a folder in the root of that project, which is there's an FV test in OMR, and in there there's there are the trill tests, and there's also various compiler unit tests. So there's different bits in both of those that we are probably interested in. Those would be the sort of pure OMR tests, and then the OpenJ9 tests. There's for that one, there's less unit testing overall in OpenJ9, but running a bunch of Java code will rapidly, like as long as we start seeing a lot of Java code being compiled, the linkages will be heavily exercised, and you'll probably find most of the major problems fairly quickly doing that. So there's kind of you have to test both. You can't just pick one, unfortunately, because they're not the same. Right? They are different in subtle ways.
Yeah. Okay, so that makes sense. I see that there is an FV test, like you are talking about the FV test, the test framework in the Eclipse OMR. So
Yeah.
there is not much documentation in the open. So
So if you're trying to get started with it, I would suggest that you join the OMR Slack, and you can ask on the general channel. Generally, that is basically just done as a make, right? So the whole thing just runs with make, and you can do make tests to run the tests. There's some documentation actually in the FB test, I believe, in OMR. Let me have a look. Where did they put it? So the CMake is in there, and did they put anything in? Where's doc? Port images, compiler. So there's the Trill language reference, but otherwise I would ask on the OMR channel, and you'll get the usual experts there to be able to suggest how it should be run. They are run as part of Sanity, so if you have a look at the definition of the Sanity build as well, that's run at Eclipse when we do the PR builds, that runs some of those tests, so you can also have a look at that.
Okay, so which Slack channel you're talking about?
So if you go to the GitHub for Eclipse OMR, there's a link to join the Eclipse OMR community Slack workspace. Just like there's one for OpenJ9, there's one for OMR. So if you click that link, it'll take you to a page where you can request an invitation, and it'll invite you to the workspace, and you can join. And that's where all the community for OMR hangs out and discusses stuff. So there's a general channel that is kind of like everything, and you can ask for some help there. And there's also some threads there about other people that have been running tests, so you can look at those.
Okay, all right. So basically, that's all for today.
Okay, cool. Anything else anybody wants to discuss? Nope. Okay, then we'll stop the recording, and we'll close this meeting for this week. And the next meeting will be in 2 weeks, which will make it the 5th of November, but I suspect that's going to collide with CASCON, which a lot of people are going to be attending.
I don't know if it will collide with CASCON. It might collide with some info talks or something like that, but CASCON is 10th, 11th.
Oh, it's a bit later. Yeah. Okay. Okay. Well, we can go with the 5th. Unless are you guys at UNB available on the 5th?
I know I am. At least so far. I'll double check my calendar to confirm that.
Harpreet, will the 5th work for you?
Yeah, it works for me.
Okay. Right. Well, we'll just stick to the usual schedule then. We'll say 5th of November at the same time. So thank you everyone for your participation. It's really exciting to see the GCR-like work concluding and being able to limit those field usages and stuff. That's really awesome work, Scott, and not easy stuff. So congratulations on that. And hopefully once Harpreet tackles the linkage, we can get the first version of MicroJIT landed.
Thank you very much.
All right. Thanks, everyone. Have a great couple of weeks. See you soon. Bye.
Thanks for coming, guys. Bye.
Bye-bye.